matter is our mitochondria are broken because that's where the heat comes from. So mitochondria are about 40% efficient. That is, they will turn about 40% of the calories that are presented to them into ATP, and about 60% will be dissipated as heat. So if you are reducing your body temperature by 1.5 degrees Fahrenheit, that means you are creating less heat, which means your mitochondria are not working as well as they used to. And so the question is, why is that? What's happened to our mitochondria? Now, just a month ago, you had Thomas Seyfried on your show. And while I agree with 95% of what Dr. Seyfried talked about, I don't necessarily agree that cancer doesn't have a genetic component. But he did say that it's about the mitochondria, and I agree with that. Ultimately, cancer cells don't need mitochondria. Cancer cells don't even have functioning mitochondria. Cancer cells ferment, and they generate the ATP based on something that doesn't need oxygen. Well, in order to burn calories, you have to have oxygen. But in order to generate ATP, you don't have to have oxygen.
Yeah, that was fascinating when I heard that.
Absolutely. That was why Otto Warburg won the Nobel Prize, was he figured out that cancer cells don't need oxygen to grow. The point is they do need a biochemical pathway. And that biochemical pathway has nothing to do with calories. So a calorie is not a calorie. And we have a limited capacity to metabolize the fructose molecule inside our mitochondria, having nothing to do with calories. Our mitochondria are very good at burning glucose. They are not very good at burning fructose, despite the fact that glucose and fructose have the same caloric equivalent of 4 calories per gram. If it was only about the calories, then glucose and fructose would be equal in terms of how the mitochondria would handle them, but they are not. This has been shown 50 ways from Sunday, most recently by Samir Softic working in Ron Kahn's lab at Joslin. Because fructose inhibits 3 central enzymes necessary for normal mitochondrial function.
And before you get into that, just to put a little bit of a pillar in the conversation that we're having right now, you're not talking about whole fruit as a healthy part of a diet. You're talking about large concentrations of added fructose, primarily, sugar sweetened beverages that are out there as a form of ultra processed foods in our diet. Is that correct?
I am talking about fructose beyond our mitochondria's capacity to metabolize it.
So a level that is beyond a whole foods diet.
That's correct. Well, remember that a whole foods diet has some fructose in it. Yes, fruit has fructose in it. I agree. Yes, it does. The question is, who's that fructose for? When you eat a piece of fruit, when you eat an orange, is that fructose for you? And the answer is no, it's not. It is not for you. And the reason it's not for you is because the fiber in that orange, unless of course you juiced it, but if you didn't, the fiber in that orange sets up a matrix, a gel, on the inside of your duodenum. The insoluble fiber forms the lattice work of the gel, like a fishnet. The soluble fiber, the pectins and the inulin, like what holds jelly together, plug the holes in the fishnet. And together, those two, the soluble and insoluble fiber that is found in an orange, will form a secondary barrier on the inside of the duodenum. You can actually see it on electron microscopy.
And you call it the duodenum?
Duodenum.
Duodenum.
That's the first part of the intestine after the stomach.
Okay, got it.
And that's where a lot of the simple sugars get absorbed. Now, you don't want to be absorbing simple sugars in your duodenum. You want them to go further down the intestine to the.
If you are attentive to the sacred frequencies, the divine voice will resound in your ears. If you tune your ears to the heavenly commandments and observe all the sacred statutes, no illness will befall you, for I am the Lord. This was a phrase found by theologian Rodrigo Silva.
Second part, called the jejunum.